Hello and welcome back to the channel. So this is the part 3 of our motion matching tutorial series. So in this video we will talk about what are our two important nodes, OffsetRootBone and the steering node. So what are those nodes, how we can use these nodes to into our motion matching system so that our character can stay in place. As you can see currently, when I rotate my joystick or my controller, the character stays in place, and when I give the input, the character properly start moving toward the desired direction. So today we're gonna talk about these functionality, and we'll cover what are these nodes. So let's get right into it, guys. So this is the current state of our motion matching project. We can see we have our running locomotion is working. We have RunStart, loop, pivots are all working fine. So first of all we'll cover these two nodes, OffsetRootBone and steering node. So in order to get understand with these nodes, I have prepared an example where I have break down these two nodes in a separate project. So if I open that up, let me open the project. So this is my separate project. So these are the breakdown version of OffsetRootBone and steering nodes. So under the hood, these are the exactly rotate root-bone nodes where we offset our mesh from the capsule, and based on the animation we try to match with the capsule direction or trajectory direction. So first of all, our OffsetRootBone, what it is. So if I only connect my rotate root-bone, so OffsetRootBone, as name suggests, it offset our mesh from the capsule. You can see the red arrow is representing the capsule direction, and the green arrow representing my mesh direction, mesh rotation, and red one is the capsule rotation. So you can see no matter what input I am giving, the character is always facing the forward, like 0. The rotation is always 0 because I am offsetting my mesh at each tick from the capsule. So if I open the code here, you can see this is the simple code where I am offsetting my mesh from the capsule, get actor rotation delta from the current rotation, and this is the root yaw difference. So I have put that root yaw difference over here, yaw value, so it keeps my mesh out of sync from the capsule. It keeps it at 0 0 all the time. Next thing is steering node. So what this will do is based on the selected animation. So let's say we are offsetting from the mesh from the capsule, and we start to move 90 left. So we have a run 90 animation picked up. So what steering node will do is, based on that rotation inside that animation, we match or we try to align our mesh to the capsule direction based on this rotation inside the animation. Let me show it to you. So if I enable that node, you can see if I rotate run 90, you can see my mesh is smoothly try to match with the capsule direction based on the current selected animation. So if we let me open the animation up, running. So for example, this is the run animation. We have mapped the rotation into a curve, same as like trajectory. You can see the trajectory is 90 left and our current direction is forward. So this rotation curve represents our mesh rotation. So we select this animation, we are using this as a deriver. So based on the rotation curve, we are aligning our mesh to match the capsule direction. So if I debug my rotation, let's say draw debug coordinate system. Sorry, debug coordinate system. Get actor location, and if I debug this rotation, this steering rotation, with the scale of this and thickness 2. Now you will see the rotation is smoothly follows the animation. It respects the animation and then try to match with the current capsule direction based on the rotation curve. So these are two simple nodes which can be used in which are used in the motion matching sample. So if I close this project now, so these are the two nodes. Now let's set this up in our project, in our motion matching project. So first of all, we need to set up the OffsetRootBone. So I'm gonna place the OffsetRootBone before my pause history. I will expose these translation mode and rotation mode. And now if I set the rotation mode to accumulate, as you can see from the property panel, you can see in this mode mesh component moves, the offset will encounter the motion. So now if I hit play, you will see that my mesh always offset from the capsule. No matter where I am looking, you can see the mesh is always facing to a forward direction. So this is the OffsetRootBone node. Okay. So for the properties, this is the translation half-life, how fast we blend from the offset. So I will set this to 0.2, rotation half-life 0.2. So this is the max translation error. So if I set it to -1 and go over here, and you can see our character is overlapping with the obstacles. If I debug the collision, you can see capsule is colliding but the mesh is overlapping with the obstacles. So you can put this translation error to 0 in order to fix this behavior. Okay, now when I hit play, you can see if I move, the mesh is always inside the capsule. Okay, so OffsetRootBone is done. Now we need the steering behavior to be added so that we align our mesh to the capsule direction properly. In order to do that, I will open the motion matching node, double click this node, open it up, and for this node we will need I'm gonna open it up. This is the blend stack. I'm gonna add a tag. So because we need the reference of this output pin, so I'm gonna reference this so that we can find out which animation are we playing inside motion matching, or which animation is selected from the database. So I'm gonna promote it to motion matching blend stack. So this will give us the desired parameter, which animation are selected and so on. So now if I add a steering node, into here, Okay, we need to put the alpha. So we only want this behavior to be active when we are moving. So I'm gonna see if we have this function is moving or not. No, we don't. So I will add a new function. Let me give a second. So I will duplicate the same function is pivoting and promote is moving. We can be in moving state. This will be true if our locomotion state is not idle. So we have our locomotion states set up, locomotion state. If this is not equal to idle, obviously we are moving. Okay, alpha will be a bool value, and I'm gonna add a is moving. There we go. For the target orientation, where we want what should be the desired rotation for our mesh. So we can use the trajectory information in order to get that. So I will get a trajectory, and we need the trajectory position at the future. So I'm gonna get trajectory sample at time. So at time of 0.5 second in future, what should be the rotation? What should be the trajectory position? So if I split the struct pin, this will be our trajectory sample facing. Procedural target time. These are all the default values. Animated target time. Okay, now we need to put the selected animation. So if I hit play now, you can see my character is stays in place. See, but we need to put the animation so that we can properly align our character to the desired direction. So in order to get our animation, that's where our motion matching blend stack node comes in. Motion matching will need blend stack information, and we need the get current blend stack anim set. This will give us the current animation which we are playing in motion matching, and we need the time get blend stack anim set time. Okay, so now when I hit play, you can see my character is offset, it stays in place. We are also following the capsule rotation, capsule direction, but we need the right animations. Currently you can see the animation which are playing. If I use Rewind Debugger and stop, you can see what animation are we playing. So this is the loop animation, loop for yeah, start, run start. Which animation we have selected? Run start right foot. So this is the right animation we have selected. So we need to place the add the animation to data into the database for our run start. So what I'm gonna do is go to my motion matching data assets database. So we have this run start database. We are missing the start animations. So if I search for start, Reface. Yeah, these reface animation we are missing. Reface. So if I put these animations into the database, reface. And now if I hit play, no, these are not the right animations. Wait. These are the animations. If I let me remove these animations first. So we need start. Just give me a sec. RunStart. We have Reface. I guess these are the right animation, but let me add these reface animation to the database again. The normalization set is not applied. I'm gonna put the normalization set and check. We have all the databases: RunStart, idle, stop, loop, and pivots all there. I'm gonna select the disable reselection to true for all the animations. And now if I play, nope, we are not selecting the right animation. So what could be wrong? What this thing? Rotation mode, accumulate. This is fine. So the issue is we are the motion matching is not selected the right animation. Let's say if I disable all the other start animations, disable these, wait, disable all these animation, and now if I play, you can see the motion matching somehow picks the right animation, but it's still not working. Okay, we can debug this. So what could be wrong here? We have added OffsetRootBone. So okay, so pause search history. Inside the pause search history, if we go to the this section experimental, we have this root bone recovery time. So we are offsetting our root from the capsule, so that's why we need to play some recovery time. Let's say if I put recovery time 0.3. Currently, if I set it to 0, you can see the details panel. If 0, the behavior will be disabled. So time in second to recover to the skeleton reference skeleton root bone transform. So if this set to 0, the this root bone offset root bone or the steering behavior will be disabled. So that's why we, let's say, put it to 0.3. And now we have added all the reface animation into the database, start database, and now if I hit play, all right. So we are playing the start animations, but our character is so the blend, I think the blend is not fine, is not good. So 0.3, go to the steering node. So if I animated target time, if I set is 2.5. Yeah. So now you can see the character is uh, properly starting towards the desired capsule direction. If I enable target smoothing its stiffness. So root motion angle threshold is 1. So disable steering below speed of 10. And now you can see we don't have any sliding when character stops. But obviously the sliding can be removed when we put our feet locking behavior in. So now you can see our character is properly stays in place and properly play the start animation for refacing. So now let's add the feet locking behavior so that our character feels more grounded and feet are not sliding all over the place. So let's set up the feet locking. So what is feet locking? So feet locking is based on so we have the animation. Let's say let's open any animation. You can see we have added the animation modifiers. If I go to the animation data modifier, you can see we have the fit speed modifier. We are extracting the speed of our ball joint, like translation speed in all the x, y, z, and map into a curve. So these are these are two of the feed speed, two curves for our feed speeds. Foot speed left foot and for right foot. So as we can see inside this animation, whenever let's say if we consider this, if you take this left foot, you can see the left foot is planted until this point and it starts animating when we pass from this point. So we will take a certain threshold, let's say for 40. So when the speed is less than, let's say 40, our feet is considered planted or a locked feet. So when our feet speed curve changes to greater than 40, we disable the lock and allow the feet to move. And you can see when the speed enter into the region of less than 40, we consider the feet is planted again. So that is the underlying logic for how feet locking is work. So if in order to set this up, we will need a foot placement node. Okay, I'm gonna set it to graph. Plant setting IK foot root bone will be our IK foot root. Pelvis bone is pelvis. Pelvis settings max offset 250 and linear stiffness 1000. Okay, just give me a second. Pelvis settings are two legs definition. We need to place the leg setting for our two legs. FK joint will be our foot R, IK foot R, ball for ball R. Okay, number of bone limbs are 2 because we have calf and thigh 2 joints. speed curve name. So this is where our speed curves comes in. So these are the foot speed L and foot speed R. I'm gonna put these speed curve names into our here. So this is for right foot speed R, and for left foot I'm gonna use again foot L. Foot L, IK foot bone to IK foot L, ball L, and then speed curve to be foot speed L. So feet leg definitions are done. Sorry, feet leg definition for feet left leg and right leg done. Plant settings. Let's say if I play. So in order the foot placement to work, we need a leg icon node after the foot placement node, so that it can work. Leg icon node is so percentage 2.99. leg definition same as it for left leg and right leg. IK foot root, IK foot root, FK foot R, and just a sec. Max minimum rotation Y, forward axis is Y. If I can open this joint, foot joint, you can see the forward axis is Y. Forward axis Y, and hinge rotation axis, in which direction it gets rotated. If I again go to over here, you can see it rotates in the Z direction. Hinge direction is Z. So we will put Z over here. Enable rotation limit to true. IK foot bone is not foot root. This is IK foot R. Now you can see our leg is properly aligned again. For definition, L, IK foot L, foot L, Y and Z. Minimum rotation to be true. Okay, that is it. Now if I hit play and see. Alright, now you can see when we start moving, our feet are properly grounded. Like the feet are not sliding as it slides before. You can see if I disable this behavior. See? The feet start sliding, and now when I enable the feet locking again, the feet start more grounded. But we have the issue where this issue, so we will fix it later. Or let's just try to debug what is the issue. Okay, so we have this issue where our feet is sliding. So this is where the Rewind Debugger comes in. We can debug, but so first of all we need to find out when this issue is happening. If I enable my trajectory, and if I slightly move right, right, and wait. Okay, so this is this is why the issue is happening. Now if I play and use a Rewind Debugger, by the way, you can go to Tools, Debug, and use Rewind Debugger from here. So now if I record my session and try to reproduce my issue, here it is. We will see why we have this issue. Okay, if I select my post search database, and this will give us our database which is currently selected and asset animation which we are currently selected. So now if I use my arrow key to move forward, so when I try to so when my character stop, this is where the issue happening. There it is. So if I go into my animation, so we have selected the RunStart database, which is fine, and the animation is not good. So if currently we can see when this issue happening, we are transitioning between two animations. This is RunStart forward and RunStart forward right. So at this point, when we release the input, the motion matching picks the stop forward, this animation, which is fine. Like this should be played, like this should be the desired animation. This animation should be played, and immediately at next frame, the motion matching picks the forward right animation. And this is happening because we have, you can see the feed velocities are in green section, are in green line. If I draw query, you can see the feed velocities are in right direction. So that's why motion matching picks the forward right stop animation. So if I open this animation up, you can see the motion matching picks this animation from this frame. So that's why we have this sliding happening, because we are selecting two animations so quickly, like transition between two animations more often. Okay, so why we are not consistently playing the same animation, but instead we are switching between two animations. So if I open my database for the stopping animation, we can see we have provided the post search schema. So we are prioritizing our trajectory, which is fine. Fine. We have the velocity weights 0.3. So we are weighting our velocities less priority as compared to the trajectory, which is fine. So now if I select this animation, okay, so looping cost bias, this one, continue pause cost bias. So this is the default value which we have 0.01. So as you can see from the comment section, and I have explained in my previous videos, that when this property is set to lower value, like negative value, our motion matching tries to stay in a same animation. So let's say this is the default weight 0.01. So the velocity changes, motion matching picks the another animation. So if I put this weight to negative 0.5 and or negative 0.05, so we are lowering this value again so that it tries to remain in the same state. it tries, so when motion matching tries to pick this animation, it tries to remain in this animation, but as you can see from the cost bar is useful to this is useful to help the system to stay in one animation segment for longer. So now we want this database to remain in that particular animation segment for longer period of time, but instead of changing it so quickly. So that's why we have changed it to negative 0.5. And now if I hit play and try to reproduce this issue again, here you can see we are no longer having that issue if we stop with the left foot. For the confirmation, if I set it to default again and try to reproduce again, see, we have this issue. Now if I set it to negative 0.05, and now if I play, see, we don't have that issue anymore. So now motion matching, we are telling the motion matching to remain in that animation segment for longer. So that is a good exercise for debugging the issues with our motion matching system. Now you have understand why and how we can use the Rewind Debugger to debug our animation issues. Okay, so we have added the steering and OffsetRootBone node and foot placement node. So we need to parameterize this foot placement. So currently if I go to the plant settings and interpolation settings, these are set to the default values. Currently you can see sometimes when I play, the feet are not properly coming back to their original position. And here you can also see that we are not pivoting properly. Our character just switch between multiple animation and not properly play the pivot animations. So first thing what I will do is, in my foot placement setting, foot placement node, so we have this plant setting. I'm going to expose this to a variable. Interpolation setting, expose this to a variable also, and promote to variable, sorry, not trace setting. We have the interpolation setting. Actually what I will do, trace setting, should be fine as it is. Let's just max ground penetration to 20. That's it. We need to parameterize our interpolation setting and the plant setting. So I'm going to create two new functions. Get feed plant setting, feed plant settings. This will be our pure function and thread safe. The output will be we'll search for foot placement plant settings. Sorry, this is not the output. Return value, foot placement plant setting. Yes, that is right. I'm gonna select. So if we are moving state, locomotion state, if it is equal to idle, then we'll have our plant setting for stop. Plant setting stops. Just a moment. Feed placement. Plant setting stops, and when we are moving, plant setting moving. I'm gonna use a category of feed placement. Feed placement, there we go. For the function, I'm gonna also select the category of feed placement. There we go. So now we need to put the settings for our stopping and when we are moving. So for stopping, I'm going to set the speed threshold to 20 and my unplant radius to 40, replant radius ratio 0.75, unplant angle to 60. And the remaining properties should be fine for my move when I am moving. We'll set the speed threshold to 60 as it is. Unplant, so we are unplanting quickly. Unplant radius, I'm narrowing down the unplant radius. We can debug that while running. If we debug the feed placement node, you can see. So we'll get into it shortly. 60 for unplant angle. Yeah, that's it for remaining. And for my plant settings, I can use my get feed placement plant settings. So we have this feed placement node debug. Now you can see this is these circles are our plant and unplant radius. So now you can see when I'm moving, our plant ratio changes, size changes. So that's why we have parameterized these settings. And similarly for interpolation settings, what I'm gonna do here is we will use feed placement interpolation setting stop, and similarly for moving. And for set the variable types to foot placement interpolation setting. Foot placement interpolation settings. Similarly, I'm going to duplicate this get feed placement feed plant setting, get feed plant interpolation setting. The output will be our feed foot placement interpolation settings. So we will select okay. So when we are idle, we will select plant interpolation setting for stop, and we are moving interpolation setting for moving. There we go. Now for setting up the stops, interpolation setting to be 250. This is the default, it's completely fine, but for moving we need interpolation of so for stopping we need the stiffness to 250, but for moving we need the stiffness so that feeds are not stiff to the ground. So we are lowering our stiffness. when we are moving. So these are two of our interpolation settings for when we are moving and when we are uh, stopping. So our feed placement node is done. We have leg IK, feed placement, feed locking is done, OffsetRootBone and steering node both are done. Now when I hit play, you can see we have a more grounded locomotion, and you can see when I switch back to the forward facing movement, our character properly orient towards the desired direction because we have added the reface animation to the database. Here you can see our stops are working fine, pivots are fine, forward facing is working fine. So I think that's it for this video. We still have some issues for our running locomotion. As you currently we can see when we are pivoting, our pivots are not properly working fine. So we will try to fix these issues in our next video. And that's it for this video, guys. I hope you like this one and you like the whole motion matching series. So let me know your feedback in the comment section, and I will see you in the next one. Bye.